There we go. Okay. All right. So you'll see the little rabbit turds, like I would like to call them. So you should draw on your in your space there. You should draw dots that are equally spaced. Okay, that's the motion, right? So on that sheet gauge right there, under constant velocity velocity, get out your pencil. Yeah. And you should draw a little ticker tape there, showing the dots consistently spaced, and then down here, the position time graph. Okay? The position time graph. Now, do you need to worry about the numbers here? I don't really care about the numbers. All I really care about is the shape. Okay? So the shape of the position time graph is, how would you describe that? Linear or straight line. Okay? Increasing straight line, maybe, you might describe that. So you should draw that, just a sketch. And you should draw the velocity. Now, because the slope here stays the same the whole time, what's the velocity graph look like? Not just straight, but flat. Okay? Not just straight, but flat. Yeah. Not just straight, but flat. And the corresponding acceleration time graph. Cole, what do you notice about the acceleration graph right here? You can put it down and pay attention.
I got next to my mother real quick. I'm sorry. I apologize.
All right. Tell you're in physics class, and it's really important that you listen so that you can learn.
It's at 0.
It's at 0. How come?
Because it's
Because the slope of the velocity time graph is flat, right? What's the slope here? Flat or 0, which means the acceleration is 0. So those three graphs all go with this kind of motion. Does that make sense? Nod. Say, yeah, that makes sense to me. I get that.
Yeah, that makes sense.
Thank you. Constant negative velocity. The opposite? Well, we saw it about 4 times. Here it is here. Constant negative velocity. Nate, we're on constant negative velocity.
Yes.
And we're drawing. Okay? So and everyone nod and say they got it. Okay? So you should be able to.
Where am I?
Constant negative velocity. First page, bottom space. Right there. Okay. So the little, think of it as a rabbit, leave the little turds on the ground.
Okay.
And the little turds are again evenly spaced, but this time they're going left, right? And you might want to include an arrow to indicate direction, right? So draw the turds going to the left, right? And the corresponding position time graph. Now notice here that the position time graph starts at 0 and goes into what territory? What territory channel? Negative territory, right? The negative region. But it's still straight. Why is it straight? Still constant speed. The straight graph indicates constant speed. The negative area indicates it's moving to the left. Okay, they're both constant, right? Now, the corresponding velocity time graph, because this slope is the same, it's straight and negative, so flat and in the negative area. Why is it flat? Because this graph, this slope is the same, right? In fact, what number is this graph at in velocity? About negative 11, right? So Lucas, what would be the slope of this line? Negative 11. Right? The value here, this negative 11 here, is the value of the slope right there. John, what's the slope of the velocity time graph? What's the slope? Okay? No, not the value, the slope. 0. The slope is 0, which means the acceleration is graphed right at 0. Does that make sense? I'm getting a few head nods, and it's not bobblehead day, so that's good. Give me a nod, Nate. Does it make sense?
I need you to ask questions one more time. I was busy.
Does that make sense? All 3 of those things correspond to that.
It's a yes. Yes, they'll be now. Yep. Gotcha.
For not wanting your picture taken, can you please go down to the multi and have your picture taken for yearbook purposes only, please, and thank you.
I have it. Okay, so let's just have a look at positive velocity, positive acceleration. I want you to write somewhere in the margin or somewhere. Okay, Nate, yearbook closed now. Time to listen.
Quit goofing around.
I want you to write signs the same. The signs are the same. What signs am I talking about?
They're positive.
Gauge. Yearbook closed. Done. The velocity sign is positive. The acceleration sign is also positive. When the signs are the same, the object does what? Speeds up. When the signs are the same, the object speeds up. The velocity is positive. The acceleration is positive.
Both they speed up. Both are positive, they both speed up.
What's both? There's only one thing.
Both are positive.
The velocity is positive. The acceleration is positive. So the little rabbit is speeding up.
Equals.
Right? The little turds are now no longer equally spaced. They are
Going to sleep.
they're speeding up, and so they're getting farther apart. What does the graph look like? It is curved, which shows increasing slope. So the slope here is 0, and then it gets steeper and steeper and steeper and steeper and steeper. The graph shows the value of the slope getting bigger and bigger and bigger and bigger and bigger. Now the value of this slope here, Nate, what's the value of the slope right here? No, value of the slope. What's the slope value here? Like 1.8. How did Mitchell know that? It's the acceleration. Right? The acceleration is the slope of the velocity. So the acceleration is graphed at 1.8.
Yeah, well, let me write that down.
Right? See that? That's exactly right. Acceleration is the slope of the velocity.
So the acceleration graph always stays.
So that's positive velocity, positive acceleration. Now the next one, many of you started already, is positive velocity, negative acceleration. Is that the next one on your list? Okay. Put on the side. Are the signs the same or the signs opposite?
Opposite.
Was it positive on the last one?
I didn't ask if they were positive. I asked if they were the same or opposite. They are different. Positive, Nate, and negative. They are different. See? Positive velocity, negative acceleration. They are different.
Out there, bud.
When they are different, then the little rabbit is doing what?
Now.
Slowing down. Why? How can we know for sure that he's moving to the right? Positive velocity. He's moving to the right because the velocity is positive. Okay. What about the position time graph? It is curved again, but it's not curved up. In fact, it's curving flat, I would say, right? Why is it curving flat? The slope of this position time graph is showing the velocity. So it's getting flat, indicating that it's slowing down. It's flattening off, indicating that it's slowing down.
Flattening off, slowing down.
Flattening off, right? Slowing down.
Slowing down.
Now, the velocity time graph, again, is the graph of the slope of the position time graph. So the slope here is positive, right? And as I progress along the graph, the slope gets closer and closer to 0. So my velocity time graph goes closer and closer down to 0. Nate, what is the acceleration in this case? The value, the number. What's the value, the number? How did Mitchell get it the last time? He looked at the
Negative 1.8.
minus 1.8. It's right there. The value of the acceleration is the slope of the VT graph. Give me the bobblehead.
Yes.
Yes? Dayton, yes?
Yeah.
Yeah? Bull? Yeah? Are you just doing that or no? Makes sense. Claire? Bobblehead or no? Yeah? What's the next one you have?
Negative velocity, negative acceleration.
That was the one we just did.
What did we just did?
Negative.
Negative velocity, negative acceleration. Now, again, the signs are the same, both negative. Signs are the same, both negative, so that means the object is going to
You haven't had your picture taken, please go down staff to the multi-purpose
This is
center,
not scholars.
all teachers, EAs, all staff
Mr.
members.
Bennett.
Yeah.
I went.
That would've been you.
I went. I bunched, I went in.
Go again.
Yeah,
Go again.
they need you.
What's up with science teachers drinking water and Mr. Christoph always just drink water all day?
We have to yell at kids a lot, we get thirsty.
Like me.
Oh, you're subtle.
He's yelling at me there.
Didn't yell at me either.
As I was saying, negative velocity, negative acceleration, moving to the left, speeding up. Little rabbit turds farther apart as you go left, right?
Keep speeding up, slowing down.
What do you mean?
Well, if you're going negative, where are you really going? To the
Means you're
left.
going left, man, that's all I mean.
Going
Okay, now,
places.
carefully here, position time graph. I'm starting at 0. Because I'm speeding up, the graph has to get, I'm looking for a word that starts with sta and ends with eeper.
Teacher,
Steeper.
can you move your hands for me?
Okay, I'm looking for a graph that's getting steeper. Is it getting steeper? Yes, it is, but it's getting steeper in a negative sense because it's moving to the left. So it starts out flat because it's slow, and then it gets steep because it's going faster. The velocity is the slope at the start. What's the slope at the start, Kia?
0.
Lucas gave you the answer. The slope at the start is 0. So where does it start? At 0. And the slope gets more and more negative. So it goes way down, more and more negative. Nate, what's the value of this slope on the UPT graph? How'd you get that?
Acceleration.
Yay! The acceleration is minus 1.8, which tells us the slope of this.
Back up.
Okay? Bob will help me. Makes sense?
Yeah.
Heather, yeah?
I got that.
Yeah?
That's not for today.
I got the acceleration part.
Almost. How many are left?
Okay, Mr. Bennett, tell me about the positions more.
Negative velocity, positive acceleration. Signs are
Relative.
opposite. When signs are opposite, the thing slows down. You can't slow up.
Okay, so speeds up. If the
Signs are the same.
Yeah, I mean,
Signs are opposite, slowing down, moving left because it's negative velocity. Because it's slowing down, the position time graph has to be getting
why is the thing slowing down? Oh, we're on
Because
one.
it
Wrong one,
is.
sorry. Gee, I'm negative and negative, sorry. I'm so tired, Mr. Bennett. I don't know how I'm going to start this football game. I'm going to pass out and I'll take that one. Gonna run in the air, I'm gonna fall over.
I'll tell you a story in a while about that.
Like the guy's gonna be so big, he's gonna be scared of it.
I'll tell you in a while.
Like 20 years.
Position time graph is, because it's slowing down, it's actually sloping flatter, right?
Yep.
Sloping flatter. It starts out fast, so it starts out very steep. Okay? Velocity time graph, because it starts out steep, the value of the velocity time graph has to be
Let's start low.
value, right? Start low. Okay, Lucas, here's the big question today.
Okay.
What is, if I were to draw a tangent line at the start here at 0 on the position time graph, if I were to draw a tangent line right there, what would the slope of that tangent line be?
Oh.
And you can tell. The answer is in front of you if you know what to do.
On the board?
Yeah, it's right there. Or you'll get pretty close. I'll ask the question again, okay? In fact, I'll do it up here. If I can pause this somehow. Let me see if I can pause it.
Don't press it, or else we'll just.
Yeah, I know.
Where's the car? One car's going now. One other car's coming.
Now I gotta go back, right? Well, I know how to do it now. I remember. If I were to put a tangent line right there, Lucas,
Yeah.
what would the slope of that red tangent line be?
0.
It won't be 0. Anyone?
Oh.
Good guess. The slope. It can't be 0, otherwise that'll be flat. It's obviously very steep.
20.
No?
Minus 20.
There you go. Minus 20, right
A
there.
lot, it's guessing
Right?
This guy.
This is the graph of the slope, right? It's minus 20 right there. If this is 5 seconds right here, What's the value of that tangent line right there at 5 seconds? About minus 12. What's the tangent line right there at 10 seconds? About minus 8. This is a graph of the slope of the position time graph.
Oh.
Gauge, what's the value of the slope of the VT graph? What's the value of this slope?
Approximately
Approximately what?
1.8.
Approximately positive 1.8. Very good. Give me the bobblehead. Mitchell, making some sense?
Make a little bit of sense.
A
Okay.
whole bunch of sense.
Tip tab.
Like, someone sent you $1.
I think you've been hanging around me too long. And that is a compliment.
What's that mean? Oh, that's really funny.
He said it makes so much sense, he's got $1.
That's awesome.
That makes me very proud, Lucas.
That's like a cheesy joke.
That makes me very proud on a whole range of different levels.
It's not good at fooling.
Might as well make good jokes, eh?
Might as well make you laugh.
Hey, you're doing good today. Okay,
100 cents is in the
I
water.
think you've got, do you have one more that I'm missing, or how does that work?
On the back.
Okay. This one's gonna be hard to draw, but I'll let you draw it, and then we'll talk about it.
Oh, wow.
I think you've got 2 graphs, don't you?
Black cars?
Holy crap.
Yeah, okay.
You got
Yeah, that's this one. That's this one. So I'll give you a second to draw those.
All of them there?
Yeah, draw the 2. Note that the first one, the top one here is position, and the bottom one is velocity, and I shouldn't have done that.
Mr. Bernard, I'm ready for the weekend.
We're almost there, Nate. Let's get through this, and then I'm going to give you guys time to work.
So what work on what? The lab from yesterday?
Yeah. Nate, are you drawing these graphs?
I talked.
I'm just taking a whole hop, skip, and a jump in the dark.
This time the numbers are a little more important. Can you at least put in the important numbers, like 20 and 4?
Mr. Bernard, can you just give me the main points, like the notes that you were talking about today? Acceleration equals velocity, slope. That's what I learned from today so far.
Okay. Well, you know what? How about we do that on the board as a group? What were the main points from today?
Yeah, that's exactly what we should do every class.
Okay. Good idea.
It's like, then I'd like retain so much.
Okay.
Retain. Because if I don't.
John, you really need to go back and see the optometrist.
I know.
Okay. So, a couple things about this one here. Let's just talk about this. We got a blue car and a red car. The blue car is obviously the blue graph, and the red car is the red graph. Which one is traveling faster?
Red car.
How can you tell?
Dustin.
Justin and Lyle.
Okay, but from the graphs, how can you tell?
It starts later, right?
There's 2 ways.
Starts like the.
So how does this car that started? How does a car start like from a dead stop and just like fly by a car and start going?
All you know is what you see, right? This car, the blue car starts at 20. The red car starts like
Grammar start.
way behind. We don't know what it's doing right now before it starts, right? Right now,
Ripping.
yeah. Well, he's already moving. He's not starting there and going instantly. He's starting way back here somewhere to the left. Right? You just aren't aware of it. You can tell the red car is going faster two ways. First of all, the red velocity graph is where? Higher. The slope of the red one up there is
Steeper.
steeper.
The one's more constant.
Can you tell me at what time the 2 cars are side by side?
7.
Here's the instruction. This is the final and last
You
call
call
to get pictures
60.
taken today. So if you'd like your picture
Okay.
taken,
Wow.
we have the multi immediately.
At what time?
Thank you.
At what time are the cars at exactly the same spot?
7 seconds-ish.
Is it right there?
Oh, that's smart, Mr. Bannon.
It's where they cross.
Ooh.
Where they cross, right? Cool.
I bumped up.
Can you give me like about 1.5 more minutes? We're almost done. Can you tell from the velocity time graph
No.
where they cross?
No.
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 Yeah.
No. You honestly can't.
You guys can't just yet,
See, but I can't.
can you?
Well, look, like right there at 10, it's like
the triangle
on
or
the
what?
other side.
We're just giving them.
You got
Because right here,
Yeah, why are they side by side there?
It's at the same time.
Why are they doing that?
Is it good there?
yeah, that's just the time. They're at the same point, they're at the same point all the way along, right? You guys can't tell quite yet. Okay, I'll be quiet. Nate wants us to kind of put down what the important parts were.
Right, no.
Not yet? Okay. If I had to summarize, can I write it right here? Is that okay?
Yeah.
Oh, I can't spell the word signs.
Buddy. It's also pretty funny though, honestly.
Signs are the same, Nate, means that it's...
You done?
Nate, I'm doing this for you.
Yeah.
Signs are the same, which means...
It's literally, hold
Same
on.
direction.
Hold your horse, buck, rowing.
Signs are saying needs speeding up.
Signs are the same as speeding up. That could be either positive, positive, or it could mean negative, negative, right? If the signs are opposite, like positive, negative, or negative, positive, that means slowing down. I haven't looked. Hold on.
This is very important.
Shut up. Calm
PT
you
graphs?
down.
Yeah,
This is great.
good level.
Remember Nate's like great talking about.
Okay, signs opposite, slowing down. The other key point, Nate, that you wanted us to put up there? How did you want me to say it? Something about slope.
Okay, gotcha.
Is that true? The slope of the PT graph is velocity?
Yeah.
And likewise, the slope of the BT graph,
One of the most important notes I've taken down all year.
what's the slope of the BT graph?
The acceleration.
Acceleration.
That was the only thing I got right.
Those are the things you needed to know.
Let me have a moment.
Yeah.
You should also be able to, if I say positive velocity, positive acceleration, you should be able to draw me PT, VT, and AT graphs that correspond. Like if I tell you what kind of motion it is, you should be able to draw the graphs.
Before we do that, you should give us some more examples. And then I'm down for it.
I'm pretty sure he's not.
There's no other examples to give you. I can give you the same ones over and over again.
You should.
Or you could just cover them up and try them yourself. Okay, you've got a few minutes, 23 minutes. Please get those labs completed if you can.
You want us
You should give me your lab report with your data, and I need 4 graphs. I need 2 displacement time graphs, 2 velocity time graphs, and I need some calculations as well. If you're done everything, I've got something that you can work on here that'll give you a head start for Monday. Now go.
Kurt, did you put
If you're needing something to work on, here it is. Or if you happen to be away Monday, here it is.
Yeah, I'm just gonna not be able to.
Why would you do that?
Other two on the computer?
You can do them right there.